Good morning, students. Yes, friends, as you know, our topic is playing with numbers, and we're doing exercise 3.2. Yes, friends, exercise 3.2. Question number 1 to 9 of exercise 3.2 is already discussed in previous lectures. So now I'm starting from 10th question. Yes, friends, your 10th question is, which of the following numbers are prime? Which numbers are prime? Question 10. Which numbers are prime? 10th question, first part. Your number is 101. 101. Now check whether number 101 is a prime number or composite number. Yes, friends, now check. Number 101 is prime number or a composite number. Yes, friends, as you know, what are prime numbers? Our prime numbers are those numbers which have only two factors. A number having two factors. First factor is 1 and second factor is number itself. So these numbers are known as prime numbers. So basically prime numbers are those numbers which have only two factors. First factor is 1 and second factor is number itself. These numbers are known as prime numbers. Now, how you can check our number is prime or composite? So simply find prime factors of this number. Now find prime factors of 101. 101 number is not divisible by 2. Number 101 is not exactly divisible by 2, 3, no, 4, 5, 6, 7. 101 is not divisible by any other number. So simply we will divide by 1. Or divide by 101. Your answer is 1. So now you can see in number 101 having only two factors. First is 1 and second is 101. So it means number 101 is a prime number. Prime number. Yes, friends? Now the question is, which number are prime? As you know, prime numbers are those numbers which having only factors. First is number 1 and second is number itself. Now check. Number 101 is prime number or composite number? Yes, friends. Find all prime factors of number 101. Now try to divide 101 with any number. It's not exactly divisible by 2. Then try 3. It's not divisible by 3. Next is 4. Last digit are 2. It's not fully divisible by 4. Then try 5, 6, 7. So 101 is not exactly divisible by any other number. So this number having only two factors. First is 1 and second is number itself. So it means 101 is a prime number. You can the divisibility of number 101 using divisibility tests. Clear? Second part is, next number is 251. 251. Now again find all find prime factors of number 251. First check divisibility by 2. Last number is 1. It means not divisible by 2. Then try 3. Sum of digit 3 plus sum of digit 3 is 8. So it means it's not divisible by 3. Then try 4. It's not divisible by 4. Then 5. Last digit is 1. It's not divisible by 5. Then try 6. So same as number 101. Number 251 is not exactly divisible by any other number. So we have 251. Again, number 251 having only two factors, 1 and number 251 itself. So it means 251 is a prime number. Prime number. Clear, students? Next is third part. Now number is 323. Part 10th question, third part. Question number 10, third part. Now number is 323. 23. Now check, is number 323 is a prime or composite? Yes, friends. Find all prime factors of 323. Try from 2. Last is 3. It means this number is not exactly divisible by 2. Then check the divisibility of 3. 3 plus 2, 5. 5 plus 3, 8. Sum of digit is 8. It means it's not divisible by 3. Then 4. No. Next is 5. 3. Same. We'll check all these divisibilities. Then at last we'll 323 will divide by 70. 17 1 or 7. Divide by 1. Now 32 minus 17. 32 minus 17. 12 minus 5, 7. 12 minus 7, 5. And 2 minus 1 is 1. Next digit is 3. Now 17, 9 are 153. Let's divide by 9. So it means remainder is 0. It is divisible by 17. So this number is divisible by 17. Now you can see number 323 having more than two factors. The number 223 having more than two factors, 17 and 19. So all factors of number 323 is all factors of 323 is 1, 17, 19 and 323. So number 323 having more than two factors. So it means this number is a composite number. It means 323 is not a prime number, it is a composite number. So your answer is no. 323 is not a prime number. Next is fourth part, 397. Now using divisibility test, check whether this number is divisible by any number, any other number. Check divisibility of 2, 3, 4, 5. So number 397 don't have any other factor. So it has only two factors. First is 1 and second is number 397 itself. So it means this is the prime number. Prime number. Clear, students? This is question number 10 of exercise 3.2. Clear, students? To check whether our number is prime or composite, simply we find all prime factors of this number and find number is prime or composite. Yes, friends. Next is question number 11th. Question number 11th. Yes, friends, your 11th question is determine 3,72,645 is divisible by 45. Is 3,72,645 is divisible by 45. Is divisible by 45. Your 11th question is number 3,72,645 is divisible by 45? Yes, friends. We can check the divisibility of this number by two methods. First method is simply divide 3,72,645 by 45. First method is divide 3,72,645 by 45. Yes, friends. When we divide this number by 45, if our remainder is 0, when we divide these two numbers, if our remainder is 0, then we can say number 3,72,645 is divisible by 45. First method is simply divide these two numbers. If remainder is 0, then this number is divisible by 45. Next is second method, by divisibility test. Using divisibility test, we will find is this number is divisible by 45. Now we will check the divisibility of 45. Divisibility of 45 by 45. Yes, sir. Simply make factors of 45. 9, 5 are 45. 9, 5 are 45. We are checking the divisibility by 45. Now, how we can check the divisibility of 45? Make factors of 45. There are two factors of 45, 9 and 5. 9 multiplied by 5 is 45. Now, check the divisibility by 9. By 9. Divisibility of 9 is if sum of all digits. If sum of all digits is divisible by 9, then we can say number is divisible by 9. Now find sum of all digits. That is 3 plus 7 plus 2 plus 6 plus 4 plus 5. Sum of all digits. 3, 7, 2, 6, 4 and 5. Now 7 plus 3, 10, 10 plus 2, 12 and 12 plus 6, 18. 18 plus 4, 22 and 22 plus 5 is 27. Sum of all digits is 27. Now divide 27 by 9. 9, 3 are 27. It's fully divisible by 9. So it means this number is divisible by 9. By 9, your number is divisible by 9. Yes. Now check the divisibility of 5. Check the divisibility of 5. By 5. Yes, friends. Divisibility of 5 is a number is divisible by 5 if our last digit is 0 or 5. A number is divisible by 5 if our last digit is 0 or 5. Now here is our last digit. Our last digit is 5. So it means this number is divisible by 5. Yes, friends. In first step, we will check the divisibility by 9. Then check the divisibility by 5. Both this number is divisible by both numbers 9 and 5. It means it also divisible by 45. So your answer is number 3,72,645 is divisible by 45. Yes. This is second method to check the divisibility of any number. Clear, students? Your question is number 3,72,645 is divisible by 45? Your first method is simply divide these two numbers. Divide these two numbers. If our remainder is 0, then we can say our number is divisible by 45. Second method is check the divisibility by divisibility test. Now we are checking the divisibility by 45. Divisibility by 45. So first make factors of 45. Factors of 45 are 9 and 5. 9, 5 are 45. So these are two factors. So in first step we will check the divisibility by 9. By 9, sum of all digits is 27 and 27 divided by 9 is 3. So it means this number is divisible by 9. Now in second step, check the divisibility by 5. Now by 5, a number is divisible by 5 if our last digit is 0 or 5. Now here our last digit is 5. So it means this number is divisible by 5. Yes, friends. Then if this number is divisible by 9 and 5, it must be divisible by 45. So our answer is this number is divisible by 45. Clear, students? Next is question number 12. Question. Yes, friends. Now, your 12th question is a number is divisible by 12. A number is divisible by 12. Why? What other numbers will that number be divisible? Find other numbers. Find other numbers by which this number is divisible by 12. A number is divisible by 12. Now find what other numbers will that number be divisible. To find this, students, we will find all the factors of 12. If any number is divisible by 12, then it must be divisible by all the factors of 12. Fact is, if any number is divisible by 12, then it must be divisible by all factors of 12. So simply find all factors of 12. All factors of 12. First factor is 1 multiplied by 12 is equal to 12. So first factor is 1 and last factor is 12. Now 2 6 are 12. 2 into 6, 12. 3 4 are 12. 1 2 3, next number is 4. 4 is already here. So all factors of 12 are 1 2 3, 1 2 3 4 6 12. Your answer is 1 2 3 4 6 and 12. So students, if any number is divisible by 12, then other numbers, which numbers is divisible are 1 2 3 4 6 12. Here we the fact which we use is that if a number is divisible by 12, if any number is divisible by 12, then it must be divisible by all factors of 12. So all factors of 12 are 1 2 3 4 6 12. So other numbers are 1 2 3 4 6 and 12. Clear, students? Next is question number 13. Now question number 13. A number is divisible by 3 and 8. A number is divisible by 3 and 8. Why, which other number will that number be always divisible? A number is divisible by 3 and 8. Number is divisible by 3 and 8. Now 3 multiplied by 8 is equal to 24. A number is divisible by 3 and 8. Now find what other numbers which is divisible by this number. Now simply 3 multiplied 8 is 24. Now find all the factors of 24. So we will use same factor as question number 12. Now find all factors of 24. So first factor is 1 multiplied by 24 is equal to 24. Second, 2 multiplied by 12 is equal to 24. 3 multiplied by 8, 24. Next is 4 multiplied by 6 is 24. Now 5 is not a factor of 24. Next number is 6. 6 already here. So when other numbers are 1, 2, 3, 4. 1, 2, 3, and 4. Other numbers are 1, 2, 3, 4, 6, 8, 12, 24. 6, 8, 12, and 20. Clear, students? So this is question number 13th. Now, last question of this exercise. State whether the following statements are true or false. Now, true and false statements. True and false statements. And false. Question number 14. Your first statement is first statement. If a number is divisible by 4, if a number is divisible by 4, it must be divisible by 8. If a number is divisible by 4, then it must be divisible by 8. No, sir, this statement is false. Because divisibility of 4 is if last 2 digits are divisible by 4. And divisibility of 8 is if last 3 digits are divisible by 8. So this statement is wrong. If a number is divisible by 4, it must be divisible by 8. This statement is false. Second statement. If a number is divisible by 3, if a number is divisible by 3, it must be divisible by 9. No. Again, this statement is false. First and second, both statements are false. Third statement is, if a number is divisible by 9, it must be divisible by 3. Yes. This statement is true. Next is 4. If a number is divisible by 9 and 10, if a number is divisible by 9 and 10 both, it must be divisible by 19. Yes, friends, this statement is true because 9 multiplied 10 is 90. So this statement is true. If a number is divisible by 9 and 10, it must be divisible by 90. True. The fact we'll use in question number 12 and 13. Same fact is this. Next is fifth statement.